Good day everyone. My name is Tercio May Sayago. I'm your discussant for today. My report is all about measures of relationship and index of determination. Measures of relationship. Correlation coefficient are statistical measures which show a relationship between two or more variables or two or more set of data. So, we use correlation coefficient if we want to know the relationship between two variables. So, when we talk about the relationship, we are talking about the manner in which the variables tend to vary together. For example, as you can see in the picture, there is a positive correlation, inverse correlation, and no correlation. If one variable tends to increase at the same time that one variable increases, we would say there is a positive relationship between two variables. And if one variable tends to decrease as another variable increases, we would say that there is a negative relationship between the two variables. It is also possible that the variables might be unrelated to one another, so that there is no predictable change in one variable based on knowing about change in other variable. Scatter plot and linear relationship. It is a helpful way to visualize the relationship between two variables. So scatter plot represents each set of pairs scored on the two-dimensional graph, which the dimension defined by the variable. So let us proceed to the two correlation tool, which is the person product moment correlation and Spearman rank order correlation. Person product moment correlation was derived by Carl Pearson in 1985, and it is still the most widely used correlation coefficient. As you can see in the picture below, the ordinal scale of measurement. When 0 to the left is a perfect negative relationship, on the other hand, when 0 to the right is a perfect positive correlation. Next is Spearman rank order correlation. It is a form of the person's product moment correlation which can be used with an ordinal or rank data. It is the same range as a person correlation and the number mean the same thing. So, here in the Spearman rank order correlation, ginagamit natin siya kapag may ini-indicate na ranking. So, the formula of Spearman rank order correlation are R sub S equals to 1 minus 6 summation of t squared over n quantity of n squared minus 1. So let us proceed to the ways to establish reliability. Number 1. Test-retest method. This method utilizes two sets of test scores obtained from the same test administered twice to the same group of students after a specified time interval. So, in the test-retest, it measures how consistent score when the same test is administered to the same individual at different times. So, we can use correlation coefficient to see if the score on the test are similar across the different administration. So, one of the correlation tool that we can use in the test-retest method is the Pearson product to find the reliability of the constructed test. Example, the following set of test scores in basic masonry were tabulated from the same group of PSIE Industrial Arts students after administering a teacher-made test at two different times. So, step 1, we need to multiply the X and Y, which is the first time was the test administered and the second time was the test was administered. For example, 38 times 29 is 1,102. And next is the X squared, in which here kailangan nating i-multiply yung X or the first time the test was administered. So we need to multiply it by itself. For example, 38 times 38 is equals to 1,444. The next is Y squared. So dito, same lang naman sa X squared, in which kailangan lang natin i-times yung second time the test was administered. For example, 29 times 29 is 841. So after natin makuha yung mga hinahanap, so kailangan natin i-total yung bawat column sa ibaba. Yung gagamitin natin na formula is R equals to n summation of xy minus summation of x summation of y over square root of n summation of x squared minus summation of x, the number size, and summation of y squared minus summation of y. So yung first step is kailangan lang natin ilagay yung hinahanap ng bawat formula. So as you can see in the example, we need to multiply the 17 times 26,999, so the result are 458,983. So next is multiply the 692 times 658. The result are 455,336. Next, punta naman tayo sa baba. So we need to multiply the 17 times 28,540. So the result are 485,180. And then multiply the 692 by itself. So the result is 478,864. Next is multiply the 17 times 25,902. It is equals to 440,334. Next is multiply the 658 times 658 is 432,964. For example, 458,983 minus 455,336 is equals to 3,647. Next naman is subtract the 485,180 minus 478,864 is the result of 6,316. Next is subtract also the 440,334 minus 432,964 is the result of that is 7,370. So next is break down the 3,647. So hindi na natin siya gagalawin kasi wala naman nakasama. Pin lang natin or i-multiply lang yung 6,316 times 7,370 is the result is 46,548,920. Next, ibaba ulit yung 3,647 and the 46,548,920. So yung kailangan lang natin gawin is hanapin natin yung square root ng 46,548,920. So, yung square root niya is 6.822.677. And the next step ulit is, we need to divide the 3,647 divide 6.822.677 is equals to 0.53. With an R value of 0.53, the teacher made tests show consistency. It means that it measures how well a different items on a test measure the same construct. It is the same formula and test-retest method is used as well as the same guide for interpretation. So next is internal consistency method. This method of establishing reliability is based on internal consistency, which involves single administration of the instrument. It includes split-half and Coder-Richardson method, wherein the test is administered at only once. It is a measure of internal consistency because the coefficient indicate the degree to which equivalent halves of the test agree with each other. In the split-half method, the test is administered once and two sets of scores from the two equivalent halves of the test are correlated. The picture below are the example of the formula. In the Coder-Richardson method, the test is given once, but to get the reliability estimate, the method does not require splitting the test in half. So the example below are the formula of the Coder-Richardson method. So let's move on my next topic, which is the index of determination. Index of determination, it is also known as coefficient of determination or R-squared. So index of determination is represented as R-squared. The R-squared it tells you how much of the variation in one variable is explained by the variation in other variable. Next definition of index of determination is it is a statistic measure that tells us how well a regression model fits the data. For example, the coefficient of determination is used to predict and explain the future outcomes of a model. So this method also like a guidelines which help in measuring the model accuracy, and it helps to get the ratio of how variable which can be predicted from other variable. The R-squared are range from 0 to 1. It means that a high index of determination that is close to 1 suggests that a model fits the data well, and the independent variable is a good predictor ng dependent variable. And the low index of determination closer to 0 indicates na yung model may not be capturing the relationship effectively. And the non-variation in the dependent variable is explained by the independent variable. Next is the coefficient of determination can be thought as a percent. It gives you an idea of how many data points fall within the result of the line formed by the regression equation. It means that R-squared is often represented as percentage. So let's move on the calculation of the coefficient. Mathematically, the coefficient of determination can be found using the following formula, where the SS regression or the sum of square due to the regression over the SS total or the total sum of square. And that's all po. Thank you.